related to this setup that we're familiar with now. And the function is, call it C for cycle, C theta. C of theta equals sine of theta plus pi over 3. And so I want you to identify and define the input of C. The input of C, the argument, and the output. So both identify like the symbols, but then more importantly, the meanings related to the cycle. Okay, related to what's going on, what you're seeing there. Okay, so take a moment, identify the symbols and the meanings of these quantities, the input, the argument, and the output related to the bike scenario. Go. Okay, so people, if you're looking at a screen, is it related to what we're doing? So laptops should be to enhance the class, not to distract. Okay. What symbols or what the output would be two outputs would be the distance that entire object is. You're right, argument. One thing in the back. Okay, so let's see how you did. Jonathan, tell me about the input of this C function. What's that? Okay, and what does it mean? So he wants the input is theta, and what's the meaning of theta in this context? Jonathan. So that's why I gave you some time to think about it and work on it. Okay? Tas, what's the meaning of theta in this context?
Is that the angle, the measure of the angle sort of counterclockwise from the position of the pedal?
He wants the pedal, the measure of the pedal angle. The measure of the pedal angle. Yeah. So it's the pedal angle measure, and then all that other studies, all that other stuff you said, important too. So the pedal angle measure. I'm not going to write it, but yes, it's crucial. Swept counterclockwise from the 3 o'clock position, right? The angle swept counterclockwise from the 3 o'clock position, and it's going to give us that angle of the pedal. Okay, what about the argument? Is that a question or just resting your hand? Okay, Austin, how about the argument?
Theta plus pi over 3.
Theta plus pi over 3. And what quantity is that in this scenario?
That's the position of the tire. It's pi over 3 radians.
Okay, so you said that that's right, the tire is pi over 3 radians ahead of the tire, but that value, pi plus, or theta plus pi over 3, as a single value, what quantity is it? What quantity is it?
I'm not sure.
Okay, well, does it relate, is that quantity relate to the pedal, or does that quantity relate to the tire?
It relates to the tire.
What about the tire is that quantity right there?
It's the measured angle swept counterclockwise from the 3 o'clock position.
Of?
Pi over 3 of the pedal. Right?
Which?
Pedal.
The pedal. So theta plus pi over 3 is pi over 3 plus the theta was the pedal, right?
Yeah.
Now we're adding pi over 3 to it.
So the tire.
Tire valve. This is the tire. This is the valve angle measure, right? This is the valve angle measure. Yes, swept counterclockwise from the 3 o'clock. So this is valve angle measure. And yes, we need all that other stuff. Swept counterclockwise from the 3 o'clock position. Okay, what about the output? Hamid?
Sine,
Sine?
theta,
Sine theta? That's it?
theta plus pi.
It's the whole thing, right? So when you have a function, the whole rule is the output, right? The whole rule is the output. And what quantity is that in this scenario with the bikes? Oh, do we know what sine is by now? Do we know what sine is? Brooke, this output sine of pi over theta plus pi over 3, what is that? Okay. She said it's the vertical distance above the horizontal diameter of the tire valve. In what unit? Feet, inches, millimeters? It's going to give one number, so there's only one unit it can be. Inches. Uh-oh. What kind of numbers are sine? What's the maximum sine can be? What is it? Radians is openness. It's not vertical distance. What is it, everybody? Radius lengths. Right? Or fractions of a radius. Remember, the maximum is 1. So most of the time, this number is going to be like 0.8, 0.7, 0.2. So it's giving you the fraction of a radius that you are above the horizontal diameter. And why is it for the valve? Why does it give you the vertical distance of the valve and not the pedal? Chola. Because you're adding pi over 3 to it. Okay, that's on the right track. Alex.
Is it because the argument is related to the valve?
Right, because the argument is the valve angle. That's what we're putting into sine. So sine is going to spit out the vertical distance of the valve angle, right? Because the argument is about the valve. It's the angle that the valve has swept. Sine will spit out the vertical distance of the valve. Okay, so this is the idea that in our argument, so we have our input angle, but then our argument is a different angle, right? So these two angles are related. And like what Austin said, that the valve angle is always pi over 3 ahead of the pedal angle. So sine of theta would relate to which? The pedal? If I just did sine of theta, would that relate to the pedal or the tire valve? Yeah, sine of theta is just looking at how the vertical distance of the pedal. And so the blue graph is for both of them, that's sine of theta. So if the tire valve is pi over 3 ahead, then what will that mean for if this is the output of this function, which is giving us the vertical distance of the tire valve? So if it's pi over 3 ahead, then what will its graph be relative to sine theta? Yeah. Y to the left.
It's a transformation of the graph. Since it's working on the input, you do the opposite. So since it's adding, you do the to the left.
No, that's just a rule you memorized. So, but we want to understand that plus makes sense. That plus, it's not the opposite of what you think. It's exactly what you think. Why does plus make sense, Jerry?
The cycle can start and finish before the cycle.
Okay, so he said that the cycle of the tire valve is going to start and finish before the cycle of the pedal because it's ahead. And so if it starts before, if it's ahead, then it's which way? Yeah, it's gonna start earlier. So we're gonna start back here earlier to the left, and it's gonna start and finish its cycle before. So if I pause this, so we start at the beginning, and I turn on. If we turn on the valve graph, what are we gonna see? So right now, so the pedal has not started. It's not started its cycle yet. But what about the tire valve? It's already started. When theta is at 0, the tire valve is already pi over 3 of its way into the cycle of going around. It's already made pi over 3 because it's ahead, right? It's ahead. And so then as so we want to see that plus pi over 3 makes sense. It's not the opposite of what we think. We want to see it as it's making perfect sense because we know that tire valve angle is greater than, so it's ahead of the pedal. And ahead would mean it's going to start and finish first. It's going to start first, and it's going to finish first because it's ahead. Okay, so and then we talked about this Thursday, and you had the web work, and hopefully it's kind of making sense. Is that a question? Okay. All right, so then in general, we want to look at sine and cosine functions that have these arguments, like adding or subtracting a value, and be able to reason this way, even if it's not the bicycle. Okay, so we're going to transition into that. Okay, does it make sense? Any questions? So let's look at this. Oops. Let's pause that. So what I want is those to be visible, but not very dark. How about that? I want it. No, not the dot. Well, the grid lines. Something like that. Okay, good. All right. So, what is this? What graph am I showing here? Christian wants sine. Agree with that? Okay, so what would it mean if we looked at, so here in blue, so can we reason about what this graph will be like? Jonathan, so tell me about sine of x minus pi over 6. So we want to understand the graph, reason about what the graph will be relative to the graph of sine of x.
Exactly.
Okay, time to shut the laptop. Jared S. How about the graph of y equals sine x minus pi over 6? We've just spent a class and a half with this whole bicycle thing to see if we can now make some conclusions about what sine of x minus pi over 6 would be like relative to sine x.
Will be shifted to the right
Why?
because it's behind. You're subtracting pi over 6.
Okay, so the argument angle is behind by pi over 6, so he's saying it's going to be shifted to the right. Why does that make sense that it's shifted to the right? Huda.
Because it starts 5 or 6 after.
Good. Right. So we expect that graph to be shifted to the right because its cycle starts after by pi over 6. So you want to see that as subtraction making sense. That here's our angles coming along. Oh, sine comes first. Well, then x sine of x minus pi over 6 starts later. Its angle's lagging behind, and then it finishes later, pi over 6 later. Okay, so that's this kind of the reasoning we're going to keep practicing as now we're going to start putting it all together, right? So there's lots of things in the real world that are modeled by sine and cosine, like lots of things that fluctuate, repeated patterns, right? Like a buoy going up and down in the water, okay? Or a pendulum swinging back and forth. Or as we've seen, any kind of circular motion, right, that keeps repeating is modeled by these. But then we have, all these different units. We got small, large, right? Things in space, things, like the size of our fist or whatever, okay? So then we have different units and different reference points. That means we have to take these sine and cosine functions and transform them to model the situation. So that's what we want to learn how to do. And you started doing that in your homework, right? Some of that stuff. So we're going to move a little harder here. So why doesn't it go up now? Can I move it to the top? Why can't I move it to the top? I guess I gotta move that to the bottom. Okay, here we go. Okay. Sorry. Okay, so here's a strategy for graphing these kinds of functions. So they basically look like this. At the top there, a times sine or cosine, b x minus c plus m. And we've talked about all these different ways of transforming and what their the implication is about the function. And so this particular strategy is a good way to kind of attack these problems. So let's put you to work here. So I'm going to put up a graph. Not that. There's the first one. Here we go. So here's a graph. And our goal is to write a function formula for it. So the first thing we have to decide is sometimes, like with the bicycle, the input is an angle, and also the argument is an angle. And so the input, if it's an angle, will be related to the pi scale. But sometimes if the input is time, then it'll be related to normally like 1, 2, 3, 4 seconds or minutes. So we want to ask, does it make sense to have a pi scale or integer scale? So I've got both. I got the pi scale above and the integer scale below. But these grid lines right now are showing the pi scale, right? So this grid is showing the pi scale. And then I can change it and I can say, okay, well, what about that would be showing the integer scale? So this particular blue graph, does its input relate to the pi scale? Or, let's look at that for a second. Does it relate in terms of the period? Or does it relate to the integer scale? So which do you think? Well, let's look at them both again. So there's the pi scale, meaning in terms of factors and multiples of pi, or factors and multiples of just whole numbers. Which one?
Can you go back?
Yep. There's the pi scale. So what do you think? I think pi scale. Because you see that starting at 0, and when does it finish a full cycle? Exactly at 3 pi. See, this is right on this grid line. Here's our 3 pi line. So it sure looks like this relates to the pi scale. Okay, so I'll leave this grid up while you... So the first thing you want to do is you want to figure out what the midline is. Okay, so we'll start with the vertical stuff first. The midline, and then the amplitude, which comes from what? Distance from the midline up to the top, or down to the bottom, down to the minimum. And then from there, we're going to find the value of b, and we get that from the period. And then we want to decide, do we want to model it with a sine or cosine? And after we decide that, then we decide how much is our curve, the one we're given, ahead or behind the standard sine or cosine, okay, without a shift. So, and that will give us this amount of the head or behind will allow us to write the argument angle, and then we're ready to write the function rule. Okay, so we'll start by, when you get to this step, sine or cosine, just go for the easier one, okay? We'll start up by going for the easier one, and once we get it, then we'll go back and we'll do the other, because all of these can be written both as a sine and as a cosine, so we're going to practice writing them both ways. Okay, so see if you can make some progress on this, okay? If you got a question, you can ask me, or Megan, or the person next to you. We can work together. So we're trying to write this curve, the sine or cosine. Exactly. Yeah, so that's why you took cosine. It is cosine. There's no shift. Sorry. Over here. Here, there you go. All right.
Is B the actual period, or did you say it was? It is the period, but we see the period, but when you say it was pi, it's also what is the point? No, so B times But that one's just real shit. That was just a midline. Yeah.
You can take the max and the min.
From the midnight up until the south would be down. And
Yes.
the P is from 50.
Well, you don't have to have tips too.
Yeah, same thing.
Just wherever.
Okay, con, midline. Did you get the midline? Two? What do you think? Is it two? Yep, it's 2. And so because it's a line, we're going to write it as y equals 2. Okay, and keep going, Con. What's the amplitude? Justin, you know what the amplitude is?
Is 5.
5. So are you looking at the height from 0? Is that what you're looking at?
Yes.
Is that our amplitude? Joe, what's the amplitude?
3.
And how are you getting 3?
5.
Yeah, so the amplitude is from the midline up to the max, or the midline down to the min, right? So you got your reference point for that amplitude is the midline. So our amplitude is 3. Okay, so looking at the graph, what's the period? P equals what? What is it? 3 pi, right? 1 full cycle. Okay, so you can go peak to peak, you can go valley to valley. Watch out for going, midline to midline, because that's not a full, right? That would be half of the period from there to there. So peak to peak or valley to valley is safer, okay? Or just make sure if you're using the midline that you make it all the way to where it starts over, okay? So if the period's 3 pi, and remember this thing. Our argument has to reach what in order to get a full cycle of sine or cosine? 2 pi. So we want that argument to reach 2 pi when the input reaches 3 pi for this function. So when that input reaches 3 pi, we want the argument to be 2 pi. So we're asking what value of b does that? What value of b will give us 2 pi for the argument when we reach the period of the input, 3 pi. So you just solve for b. Remember doing that? Don't forget. So that just keep practicing this reasoning. So b is 2 pi over 3 pi, or 2/3. Okay? And so the easier choice, sine or cosine? Corey? Cosine. And how much is our graph, our curve, ahead or behind of the standard cosine? So how much ahead or behind? If we were to sketch the standard cosine starting at 0, then how much would our blue graph be ahead or behind that? What's that? 2/3? Alex? It wouldn't be. Yeah, it would be right on. So if we sketch cosine, it would be right on top of the blue curve. So none. So if we choose cosine, it is cosine, right? It is cosine. So now we're ready to write the function rule. Y equals, anyone, Patrick, did you get that? Can you do it on the fly? So here's our general form. Cosine. Three. He wants 3. What do you think? Yeah, remember, so cosine would go between what and what? -1 and 1 radius lengths above and below the midline, right? So, but this goes with 3, and so that's our, think of it as like 3 feet or 3 miles, right? Okay?
And the cosine of 2/3 time 2/3 theta.
We're going to use x
Or x, yeah.
because that's our generic input. Okay?
And it's above, the line is above 0 would be, so you have to add a 2.
Right, so just how much does the midline move up from cosine? Midline of cosine is 0. Now it's 2, so the whole thing shifts up by 2. And then what about the argument here? Do I need x plus or minus something?
No.
No, because we said it's not shifted, it's not ahead or behind. Our argument angle is not ahead or behind our input angle. So that's it. 3 cosine 2/3 x plus 2. Alex?
What's that B term is
B?
what is it? Yeah, B.
Okay, so it takes a while to stick in. We did this a week or two ago. So the argument,
You're using the radius?
B?
Yeah.
No. No, it's not the radius. The radius is like the amplitude, right?
I'm sorry, I meant from that function f over x. Yeah, the function.
B?
Yeah.
No, B doesn't have, A is like the radius of the circle.
Oh, yeah.
A is like the radius of the circle. Okay, so this is our argument. And the argument, if we get a full cycle of sine or cosine, then the argument reaches what? 2 pi. So we know the period in terms of the input, right? What's the period in the input? 3 pi. So when that input, so theta is a changing quantity, right? It's all these values. But when it hits the period, that's when we want the argument to hit 2 pi, because we get 1 cycle. So when that changing input quantity is 3 pi, we want that argument to be 2 pi. And that's, so we're asking what coefficient makes that true? What coefficient B will make that scenario happen, that when we reach the input that gives us a full cycle, it will make this whole argument be 2 pi. So I'm just dividing both sides by 3 pi. Is it better? That's 2/3.
I understand like how to do it, but I guess like just why.
I just went through the whole why. Because cosine or sine, what is the full cycle in cosine or sine? 2 pi. So that's going to be our argument, right? So our argument angle needs to hit 2 pi. The argument angle. So like,
Very much trying to equal your
so sine of, so this, when this hits 2 pi, this whole thing hits 2 pi, we're going to get 1 cycle of sine.
okay.
So, but we know for the input in this particular function, that's 3 pi. So when 3 pi is put into this function, we need this argument to be 2 pi so that we get 1 cycle, and we're asking what value of B will do that. So B times 3 pi has to equal 2 pi. Is it better?
Yeah.
Okay. Okay, now write it as a sine. Oh, go ahead, Patrick.
Actually, I have one question.
Yeah.
Why does it not lag ahead or behind? Because wouldn't the full cycle be finished at 2 pi, not at 3 pi?
In this graph, in terms of the input quantity here on the x-axis, in terms of x, you don't finish a cycle until 3 pi in terms of the input x. So what's your question again?
I'm saying that why, if we made a normal sketch of just cosine, wouldn't it not end at 2 pi? Like, would it not do 1 full period at 2 pi?
Yes, that's true.
Would that then be lagging behind our graph?
No, it's not a lagging behind or being ahead. It means you take the whole graph and you move it like this. Changing the period is like squeezing it and stretching it, right? So our starting point at 0 stays the same. And then for a longer period, it's like you're grabbing it and stretching it out this way. For a shorter period, it's like so that's not a matter of ahead or behind anymore. Does that make sense? Yeah. Head or behind it's the exact same curve, and we're just saying, oh, it starts earlier, or it starts later. So you move the whole thing. Other questions? These are good questions. Okay, how about same one, write it as a sine function. Write it as a sine function. So will the midline change? We write it as sine. Will it be a different midline? Up and down? No. What about the amplitude? No. What about the period? We write it as sine. Will it change the period? No. So period's still going to be 3 pi. Period b will still be the same 2/3 we found before. So now we're choosing sine. So what you have left is you got to imagine or sketch. Imagine or sketch sine. So where does sine start at 0? At x equals 0. So does it start at the minimum, at the midline, or the max? Sine starts at the midline, right? Vertical height above the horizontal diameter at 0 is at that horizontal diameter. Okay? And then
2x at 0 in this case.
midline. So sine, just think of sine starting at the midline of the circle. Yeah. All right? And so then what does it do? It goes up to the max, right? Like this. Okay, so just imagine a cycle of sine. And so now our curve, the blue one, how much is it ahead or behind of this traditional or standard sine? And that's going to determine how you're going to create the argument angle, right? So how much is it ahead or behind? So maybe I need to tell you what these are here. So each of these lines is pi over 4. So this is pi over 4, negative pi over 4. This is negative pi over 2. And that right there is negative 3 pi over 4. Because each of these vertical lines is pi over 4. So, is our blue curve ahead or behind the standard sine curve? Brian? It's ahead. Okay, by how much? How much is our blue curve ahead of standard sine? Can you read my scale, what I wrote over here? Can you read those? Each one is pi over 4. Three pi over 4 ahead, right? So our curve is starting 3 pi over 4 ahead of the actual sine curve. All right, so who wants to try writing the whole thing? Nina.
Okay, so what I have is 3 sine, and then it's the same 2/3 x.
We got to do this in parentheses.
Oh, okay, 2/3, and then x plus pi, 3 pi over 4.
Is that the whole thing?
Plus 2.
What do you think? Does it make sense? So everything's the same except, so now we're doing sine, and with sine we need to say, oh, if this is a sine curve, oh, it's starting ahead of the normal sine curve by 3 pi over 4. So I'm going to do my argument angle is going to be a greater angle because it's starting ahead of time, right?
Is that a constant relationship that you're gonna see between cosine and sine? As in,
No.
it's gotta be
Don't look for tricks and rules. Just reason it out every time. Yeah, no, it won't. Meaning what? That sine will always be, you'll always pick ahead of if it's cosine?
As in, yeah, pretty much like the distance, say you just change all the numbers and, go would be like 3 pi over 4. Like,
No,
not,
no, they're all different.
okay.
They're all different. So just, go ahead and do each one separately. Don't try to, watch out for making rules because usually there's cases that break your rules, right? Any other questions on this one? Yes, sorry.
I also think it could be that they can
Okay, behind how much? Right. He wants sine to be behind. By how much?
As I say, it should be 2.25 times
2 pi plus how much more?
1/4.
1/4 pi. Yeah, so what he's saying is, oh look, it's also, you can also say it's, if this was the cycle we were looking at of sine, then this one is, what, 9 pi over 4, because 2 pi is 8 pi over 4. So this cycle is 9 pi over 4 behind, lagging behind. So you could do x minus 9 pi over 4. And that would be legit. Yeah, absolutely. It's just, it's usually the easiest to find your closest one, to find the closest cycle of sine in your blue graph. But that's totally legitimate. You could do x minus behind 9 pi over 4, which is this 2 pi plus pi over 4. Good question. Yeah?
I think piggyback on what he was saying. So if you were just had one, you just had cosine functions
Right.
by itself, would there just not be ahead or behind? You'd be right on if you're not comparing it to a sine function, or would you always have? Would you just have to evaluate how it is?
No, this particular curve starts at the max and goes down from there. That's exactly what cosine does. So that's why when we said cosine, there was no shift. Does that answer it?
Yeah.
Okay, yeah. So we're going to see another example. Other questions? Okay, so try this. Okay, so the first thing I'm going to do is we're going to look and see, does the scale relate to multiples of pi, or does it relate to integers? So this is right now I've got the grid lines at multiples of pi, pi, 2 pi, right? Every grid line is pi over 4. Okay, and then here is relating to, see, here's your grid lines are on integers, whole numbers. Okay, that double line is your x-axis, okay, just so you have that's the x-axis, okay? So what do we think? Does this graph relate to whole values on the x-axis, or does it relate to multiples of pi? So there's your multiples of pi. There's your whole values. Whole values. You should see that this is lining up with 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here's your strategy. Start with the easier one first, but do both, okay? So when you get to this sine or cosine, start with the one that would be naturally easier, write that, and then go back and write it as the other, okay? Do it both ways.
But if you're using cosine always starts at your max, right? It always starts at here, right? Well, how much?
Oh, like a half.
It'll probably that's a lot.
Starting at zero. It's not really.
Yeah, what?
Yeah. We have one more exam next week. Wednesday or Thursday. Choose. Okay, let's see how we did. Malin, tell me about the midline. So because it's a line, yeah, so because it's a line, we want to write the equation of the line. Y equals -1. Okay, what about the amplitude? 2. Is everyone good on those? That's the easy part, right? So the midline is -1. Distance from the midline up to the top is 2. Okay, you're doing good. So what did you see that the period was here? The period is pi. Is the period pi? So there's two different values. There's the period and there's the value of b. So I'm asking for the period. What would that be? Yeah, so 2. So where does it start over? So if we started here? 2. So the period is 2. And so our value of b is the number that when multiplied by 2 will give what? 2 pi. So if their input is 2, we want the argument to be 2 pi. Therefore b is pi. Okay, so more easily, Audi, sine or cosine?
Sine.
If we choose sine, how much is our graph ahead or behind sine? So if I choose sine, if I were to sketch just sine with no shift, how would our blue graph compare to that? Would it be ahead or behind?
I'm going to go with no shift.
No shift, right? If I were to sit here and start drawing sine, it would be right on top of our blue graph, right? Given that period of 2 and that amplitude of 2, it would be right on top. So if we choose sine, none. It is a sine. It is sine. Okay? So function rule. Justin, did you get it?
I said y is equal to 2 sine, and in parentheses, pi x minus 1.
What do we think? Got it? Okay, cool. So now it gets a little more challenging. We got this last, so we're writing it as a cosine. So what would it mean to write it as a cosine? Can I erase? Anybody have a question on the sine version? Okay, so as a cosine, midline, same. Amplitude, same. Period. B value is the same, pi. So now we're going to choose cosine. And so we can, this is helpful. So start by sketching cosine. Does cosine start at the min, the midline, or the max? max. And in the first quarter, it goes to the midline. In the second quarter, down to the min, over on the left side of the circle, right? So here is cycle of cosine. Now we're asking our graph. Is our graph the close? So there's many cycles of cosine you can pick on our graph, but we're just going to pick the closest one. So the closest cycle of cosine, our graph, ahead or behind just cosine by itself, the red one. Ahead or behind?
It's behind. It's starting at.
So the closest cycle is this one here. So I'm going to overlap in black. Kind of. Oh wow, that's really bad. Anyway, you get the idea. That's the cycle that we're looking at. So that cycle of our graph, the one we're writing the function for, ahead or behind the red one? Starts later and ends later, so therefore it's behind. It's behind. It's coming later. So now and by how much? A half, right? So this is 0.5 on our x scale. So it starts 1/2 unit later. So who can write the rule? Armar, cosine rule. Can you do it?
Yeah, the cosine rule would be a half of x.
Y equals, okay.
Okay, y equals a cosine.
And what's A?
A in this case is the min 2.
2.
Yeah. Cosine.
Cosine.
Parentheses b, which is pi.
Pi.
The parentheses x
X.
minus. Oh, sorry. Yeah, minus a half.
Minus a half. Is that consistent with what we said?
Yes.
It's behind. It's trailing behind. So its angle is less. That's right. The argument angle is less.
Minus 1.
Here's what he wants. What do you think? That's it. Anybody have a question? Okay, let's just get perfect here. So let's skip to this one, maybe. Go. Oh, so I got it first. Let's decide what scale. So here's pi scale. Well, let's just start here. This is integer scale, right? Whole number scale. So just study it for a second. Do you think it relates to the whole number scale? Okay, or here is pi scale. Those grid lines are multiples of and fractions of pi. These grid lines are every whole number. People are saying whole numbers.
Yes.
They are correct. Go. Both sine and cosine. They're all sine graphs. They're all sine graphs. And they're all cosine graphs. There we go.
They're not just like that. It doesn't start with the sine and start with one of them should be 1. The other one should be a G1. But if you're going to go to actual time, where it's a positive or negative, is that how cosine is 1? But I don't know. So
Cosine's at a what?
it's going to need a shift of 1, but I don't know whether the 1 is going to be negative.
So where would cosine start?
Negative 1.
Yeah, it is starting at negative 1/2. Yeah, so that happens. Is our curve actually ahead?
Our curve is half.
You got to sketch. You can imagine sketching a cosine. Right? So where does the cosine start? Min, midline, or max?
Start at negative 1.
Right. Negative 1.5? Max?
1.5.
So ours.
Oh, so this first curve starts first.
The focus is ours. Is ours ahead or behind the standard cosine? It's ahead.
So then sine, because it's starting later. It's going to start at the midline and the midline.
Yeah, you
0.5
One more round of questions.
ahead because the midline.
You have to think about sine when it starts at 0.
Yes. Oh, okay. So that was going down. So it's actually 5. Yes, ahead, but.
Yeah, you can technically make behind you.
Okay.
It's like a low further way out.
They don't have to wait. They're not waiting. But the tangent function, yes, we will. Okay, Walter, midline. What's that? Negative 2. So if we want to write that as the equation of a line, y equals negative 2. What about the amplitude? 0.5. What did you count for the period here? So how much, what's our interval of input? That gives a full cycle of output. 6. And how? What? And then, so b times 6 needs to reach 2 pi. So what's b? Solve for b, pi over 3. Okay, Jaden, what do you want to do first, sine or cosine?
Cosine.
Cosine first.
Yes.
All right, so we have to imagine or make a sketch. I think it's good to make a sketch. Just cosine with no shift. Cosine with no shift. So start the min, the midline, or the max. Just Jaden.
That would be half.
What?
What?
The cosine, just the cosine without a shift. Does it? Will it start at the min, at the midline, or the max? The max. Okay. So here. Is, did I screw that up? It's got a 6, right? So 3 is going to hit the low point. Something like that. A little more curvy. But so now our graph, Jaden, is our graph the closest cycle of cosine ahead or behind that? Ahead by how much? What? A quarter cycle, right? But how much x? Right? Yeah, it's ahead by a quarter cycle. That's true.
Okay, so I have something.
Yeah, that's true. But what is a quarter cycle on our scale here?
Oh.
How much is it ahead?
So it would be 1.5.
No, it's ahead this much, right? Not 1.5. How much is it ahead?
And 1.
1.
Oh, wow. Okay, yeah.
Right? So you're right. It's a quarter cycle, but that's 1 in this graph. Okay, so it's our graph is ahead by 1. Okay, so who wants to write this? Fuda, can you write it? Okay. Good. This is what she wants. It's ahead by 1, right? So our graph, the blue one, is ahead. The standard cosine, or the cosine without a shift, it starts ahead by 1. So the argument angle is 1 greater. Okay, so then as a sine, what's going to change? So I'll leave it up. So are we good on cosine? So for sine, Shola, you're up. So what's going to change? This is going to change. So when we change it to sine, now it's, so ahead, is ours ahead, the closest cycle of sine to the origin here, or to the y-axis? Is it ahead or behind ours, a sine with no shift? How much behind? What's that? He's looking at this right here? -2? So the sine graph, you want me to draw it? I'll draw it in black. So the normal sine will start at -2 like this. And its period will be 6. So it will, at 1.5, it'll hit the max. And then it'll be back to the midline at 3. And then down to the min at 4.5. That's the best sine curve I've drawn all day. Okay? Thank you. Thank you. Okay. So so you got to look at the blue graph. You're looking for a cycle of sine that's close by. The blue graph, is it ahead or behind the black one? Behind. By how much? 2? It's behind by 2.5. What do you think? No. It's ahead. It comes first, right? Here comes the angles. Which cycle starts first? Blue or black? Blue starts. It's ahead. And then black starts. and then blue finishes, and then black finishes. So our graph, if we're using this cycle starting right here, our graph is ahead. Yeah, Alex.
Is there a way to, I guess, flip them? So instead of having your sign start, at your midline, and goes up to your max, have it start at your midline and go to your minimum?
That's negative sign.
Okay, so you can.
You can do it, but that's the opposite of sine. It's
Okay.
taking all the outputs and taking their opposites.
Okay.
So, yeah. You can do that as long as you know it's the opposite of sine. So we're ahead by how much? 2.5. So add or subtract? Add. Okay, if you want, did anyone do a sign with ours being behind? If you pick the next cycle of sine, which starts here, this one is behind how much? 3.5. So you could also do x minus 3.5 because there's a cycle that starts at 3.5. So it would be starting 3.5 later than the black one. So you could also, in the parentheses, have x minus 3.5. That would be right too. Questions? We got one more thing to do. Okay, so now in your homework, you're doing these problems, but then there's applications where you're doing an additional thing at first. You're given a paragraph describing the setup, and before you can dive into this, you have to make a sketch of the graph. Okay, so here's an example. So the tip of a wind turbine blade reaches a high point above ground at 78 meters and a low point of 30 meters above the ground. At a certain time, the turbine spins once every 3.5 seconds. The blade tip in question starts closest to the ground at t equals 0, and the turbine spins counterclockwise. So you need to write a sine and cosine function to model the height of the tip above the ground. So we want the height of the tip. Oh, jeez. So write a function to model the height of the blade tip above the ground. T seconds after t equals 0. So what do you have to do first? You have to make the sketch of the curve based on what you're reading here. You've got to figure out, when does a min occur? When does a max occur? When does it go through the midline? And where is the midline? Where's the max? Where's the min? And so you have to come up with the curve first and then do what we've done all class. So we're going to practice making the curve. You got a minute. So can you make this curve? Turbine spins around once every 3.5 seconds. That's the period.
So it starts at 30 meters.
It starts closest to the ground. Right. That's right. Okay, so what'd you do? The minimum's at 30, maximum's at 84. Give me a midline of 78, sorry. That gives a midline of 54. And then the period is what? 3.5. And so we're going to split it up into 4. So 3.5 over 4 is 0.8 something. And then 1.75. And then whatever that is, 3/4 of the way. And then it tells you that it starts at the minimum and it's going to head up from there, right? So this is your, what, 30, 54, midline, 78 max. So there's your sketch to get started, and then you do exactly what we did in class, right? So everything we did in class now, you're pros at. And you can do it. Questions on that? Okay, if you got a question, you can grab me on the way out.